Right, so my last video was so rudely cut off at 15 minutes, so I didn't have a chance to finish this last problem, so let's go ahead and start it again. When we're finding the probability that a dart or some point randomly will end up in the shaded region, one of the ways that we can do it is we could find the area of that region and put it over the entire area of the object. So for instance, if this had a radius of 4 centimeters and that was 20, I could say the area of the total circle would be pi times r squared, which is 16 pi. And then I can find the area of the arc, or the sector, I should say, the sector would be 20 degrees over 360 times pi r squared, which we've already calculated that. So I know this is going to be 1/18 of 16 pi. When I reduce that, I get 8/9 pi. So now to find the probability that something randomly lands in this section, I could say my part, which is my sector, 8/9 pi over 16 pi, the whole part, and that would be, let's multiply each of these by 9. So I get 8 pi over 16 pi times 9, and 8 and 16, pi and pi, they reduce, so I get 1/18. All right, so let's talk about an easier way of doing it. Instead of finding area, okay, so I'm going to erase that. That is one option. You can do that calculation. The other option for a problem like a circle is I notice that 20 degrees goes into 360 nicely. So if I take 360 and I divide it by 20, I get 18 equal pie pieces. 18 equal pie pieces. So I mean, I could draw all 18 of these pie pieces in. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 18. Just imagine there's 18 in here. Well, I'm only looking for the probability that the point lands in 1. So I have one part out of how many equal pieces? One of these pie pieces out of 18 parts or equal pie pieces. So the probability that it will land in this is 1 out of 18, which I find a lot easier than doing it using area. And that's it for the Chapter 10 review. Study hard for your Chapter 10 test.